Hey everyone, my name is Sahil, and in today's video, we will discuss the important quality tests for medium voltage insulation piercing connectors such as this one, carried out as per BSEN 50397 Part 2. But why should you listen to me? At Axis, we've been manufacturing and supplying overhead line hardware, including covered conductor accessories, for more than 30 years. Our products are trusted by more than 80 utilities across the world, including in India, Africa, Latin America, and everywhere. So what is an MV insulation piercing connector? This IPC is used to connect a medium voltage branch conductor to a main covered conductor without removing the insulation. It pierces the insulation and establishes electrical as well as mechanical connection in a single operation. To make sure that your IPC performs reliably in service, it must pass the following tests. Firstly, the torque application test. This test ensures that the tightening of the IPC is carried out correctly and consistently during installation. So how is this done? The IPC is installed onto the conductor that is tensioned to 20% of its minimum breaking load. It is tightened to the maximum recommended torque plus an additional 20% as per the manufacturer's installation instructions. The tightening must be carried out at a controlled rate, approximately 1 full turn in 8 seconds, or at the rate specified by the manufacturer. Your IPC passes this test if it remains undamaged after tightening. The second test is the shear head function test. This test checks whether the shear head breaks at the correct torque, so that proper electrical contact and mechanical tightening are achieved without over-tightening or under-tightening the IPC. So how do you conduct this test? 3 IPCs are tested at 2 temperature conditions. Firstly, the minimum temperature of -10 plus or minus 3 degrees Celsius and the maximum temperature of 50 degrees plus or minus 3 degrees Celsius. The IPC assemblies are first preconditioned until they reach the required test temperature and are maintained at that temperature for at least 15 minutes. The shear head is then tightened as per the manufacturer's installation instructions until the head breaks. The torque at which the shear occurs is recorded. The IPC passes the test if the shearing torque stays within the manufacturer's specified tolerance. The third test is the branch cable pullout test. This test checks whether your IPC can securely hold the branch conductor under mechanical load without slipping or failing. So, how do you conduct this test? 2 samples are tested for the required conductor combinations on tensile testing machines. The IPC is positioned and installed according to the manufacturer's instructions. The conductor is marked near the IPC to monitor any slippage during the test. A tensile load is then applied approximately in the axial direction between the branch conductor and the opposing main conductor at a rate between 1000 newtons per minute and 7500 newtons per minute. The applied load must be 1 kilonewton or 10% of the breaking load, whichever is less, and this load is maintained for 1 minute. The IPC passes the test if conductor slippage does not exceed 3 mm and no failure or damage occurs that would affect its correct functioning. If you're finding these tests helpful, please subscribe to our channel for more insightful videos on electrical engineering. The fourth test is the low temperature assembly test. This test checks whether proper electrical contact is established when your IPC is installed in cold conditions. So how do you do it? 2 samples are tested for the required conductor combinations. The IPCs and conductors are preconditioned to a temperature of -10 degrees Celsius plus or minus 3 degrees and must reach this temperature before assembly. The IPC is then installed inside the cold chamber according to the manufacturer's specifications using a torque meter during tightening. Electrical continuity between the main and branch conductors is measured, and the torque at which continuity is achieved is recorded. The IPC passes the test if electrical continuity is achieved at a specific torque. That torque must be less than or equal to 70% of the manufacturer's specified minimum installation torque. The fifth test is the water tightness test. This test checks whether your IPC prevents water from entering the conductor after installation. How is it done? The IPC is installed on the covered conductor according to the manufacturer's instructions. The conductor along with the mounted IPC is then immersed in water at a depth of 300 mm. This immersion is maintained for 24 hours. The IPC passes the test if no water penetrates into the conductor and no moisture travels along the conductor strands. Now number 6, the climatic aging test. This test checks whether your IPC can withstand long-term sunlight, temperature variation and environmental conditions without degrading. So how do you do it? 2 samples are tested. The IPC assemblies are subjected to climatic aging cycles as defined in the standard. The test runs for 6 cycles, 1 cycle per week. During this period, the samples are exposed to controlled temperature variations and light with maximum exposure on the synthetic paths. After completing the aging cycles, the samples are stabilized at laboratory conditions. Visual inspection is carried out to check for degradation of organic paths and to make sure markings are still legible. The IPC must also meet the water tightness requirement after immersion for 12 hours. Your IPC passes the test if no degradation affects its function, the markings remain clear, and water tightness is maintained. I hope you now have a clear understanding of how the medium voltage insulation piercing connectors work and the quality tests they undergo. Note, there are more tests. However, these are the most prominent ones. At Access, we ensure that our IPC is subjected to these comprehensive tests in our NABL and UL approved testing lab. We never compromise on quality, which is why millions of Access insulation piercing connectors are installed across the world. Before you move on to another video, remember that even the best tests can't compensate for inadequate installation. Watch this video to learn about the correct installation procedures for IPCs.